Okay, so today we're going to look at sketching cubics and quartics, and I'll explain what they are in a second. But to begin with, we've got to think about quadratic graphs. Now, we all know what shape a quadratic graph has, and a quadratic graph generally has a shape a bit like this, and it could be anywhere on the curve, it could even just touch the x-axis, and all of those are positive x squared curves. So in other words, the highest power that the x has is a 2, a power of 2, so it's an x squared, that's the highest power, and that x squared is a positive x squared, so it could be plus 2x squared, plus 5x squared, just plus x squared, but it's positive. When you have a negative x squared, then your curve goes upside down. And again, they can just touch the x-axis, they can go through the x-axis, they might not go through the x-axis, they might do one on one side, one on the other. It doesn't matter, it's just upside down. So they're the different types of curves that you could have for a quadratic, both positive and negative. Now, a cubic is exactly the same in that you can have a positive version and a negative version. And cubics are when the highest power of x is x cubed. So it could be x cubed plus 5x minus 2. It could be 3x cubed minus 2x squared minus x minus 7. But the highest power is the power of 3. And positive cubic graphs look like that. And again, that could be anywhere. It could go through the axis, the x-axis 3 times. You can have situations where they're quite steep and it might just touch the x-axis and do that. I'll do a different colour one. You might have ones where it never goes through the x-axis, but it always starts in the bottom left, up and over, down and up, and it finishes going high. And the reason we know it finishes going up high is because when you cube a positive number, you get a very big answer, okay? And so as x increases, x cubed increases, and so you know it's ending going up to the top right, okay? So that is your positive x cubed graphs. Obviously, we can have negative x cubed, and just like with our quadratics, it gets flipped upside down. So negative x cubed graphs, again, have the two curves, the two bends, but this time it starts in the top left and finishes going down to the bottom right. And again, they can be anywhere. They can go up high, down low, anywhere below here like this. It doesn't matter, but they always start in the top right and then top left, and end in the bottom. And the way you can think about that is if you have a negative x cubed, well, you're taking the minus of an x cubed. So if as x gets bigger, x cubed is going to get bigger, but when you then put the negative sign in front of it, it means it's getting smaller, okay? And finally, we've got our quartics. Now, quartics are when the highest power of x is 4. So we have an x to the power 4. Okay, and you'll see a pattern now because our cubics started with almost one bend in them. Sorry, our quadratics started with one bend. Our cubics had 2 bends. And guess what our quartics have? Our quartics go bend, 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 and back again. So effectively, each power of x that you add on creates another turning point. We call this a turning point when it bends from going down to up or from up to down. And again, this is your positive quartic. So this is your positive x to the power 4. Because again, as x gets bigger, x to the power of 4 is going to get very big. So again, they can go like this. They can be up in the air. They don't have to. Sorry, I should draw that as more of a curve. They don't have to. You can have them come really low and really quite small. Okay, they don't have to, they're not symmetrical in any way. Some are, but the vast majority are not symmetrical. So again, you could have one where it touches, comes up, then comes very low and goes back up again. all sorts of things. And that's your positive. And guess what? Negative is just upside down. So it just goes like that. All right. So negative ones, try a few different colours. They can touch, come down, and not necessarily touch like that. But again, there's that 3 bends. Okay. So that's the different types. So you've got your quadratics, your cubics, and your quartics. So when you're drawing a graph, you have to make a few decisions to be able to sketch these graphs properly. And the first one is you have to decide what type of graph is it. Is it an x squared, an x cubed, or an x to the power 4? It goes higher, but that's where we stop for this particular course. What type of graph is it? Is it a cubic? Is it a quartic? And you've got to decide whether it's a positive or negative, because that tells you then the basic shape. Is it the standard one or is it the upside down one? Okay, so that's your first decision that you've got to make. So I'll tell you what, we'll decide and we'll do 2 in sync. So here we go, I've got sketch y equals x cubed plus 3x squared plus 2x. So I think it's fairly obvious that's a cubic. And because the x cubed is positive, it's a positive cubic. So if I just draw a little sketch of myself, I know it's going to look something like that. Okay, so that's the first decision. What type, and is it positive or negative? The second thing you need to do is find where they cross the axes. Okay, so that's when you, because obviously for any sketching of graphs, we've got to write the numbers where it crosses the axes. So here we go, axes. Well, for our y-axis, we set x to equal 0. So in this case, I get y is 0 cubed plus 3 lots of 0 squared plus 2 lots of 0. Guess what? Y is 0. Okay. Now I need to find where it crosses the x-axis. So I set y to equal 0. So I've got 0 equals x cubed plus 3x squared plus 2x. And this comes back to what we've been doing in the previous couple of lessons. I've got to factorise this. Now if we look, they've all got a common factor of x. So I can say that's x squared plus 3x plus 2. And actually that quadratic now that's inside the bracket is quite a simple one. And I get x plus 2 and x plus 1. So again, all of these are equal to 0. So either x equals 0, x equals minus 2, or x equals minus 1. So when I'm doing my proper sketch, I know it crosses at 0, at minus 1, and at minus 2. And this is where I had to make that decision as whether it was a positive or negative. Because on a graph like this, I've got 2 choices. I could draw it like this, or I could draw it like that. And I've got to decide which is the right one. Well, I know it was a positive cubic. Positive cubics start in the bottom left, come up, down, and start by going up to the top right. So I know that the purple is incorrect, the blue is the right one. So actually that's how I should have drawn it. Okay, and I need to put my information on my graph. So I knew it crossed at minus 2, minus 1, and the origin, and there's my perfect sketch. So the next thing we have to consider, which I'll look at in a minute, is touches, and I'll explain that in a couple of examples when we come to one. Okay, so sometimes they present it like this, and this is fantastic because they've done the factorization for you. So again, we've got to decide what is the type. Now looking at this, it's a bit more tricky to think about what type it is, but if I think about expanding these brackets, when I expand these two, I'm going to get an x squared plus something plus something. And then when I multiply that one in, I'm going to end up with an x cubed. So the way you can think about it is I've got an x times a minus x times a 2x. So what would that give me? That would give me minus 2x cubed, because I think this multiplied by this multiplied by this. So the type is a cubic, and it's a negative cubic, not a positive, a negative, because we've got this minus x in this central bracket. So if I think just a quick sketch of what negative cubics look like, they start high, come down, up and down again. So that's the shape that I'm going to be doing. I now just need to find where they cross the axes. So again, on the y-axis, we set x to equal 0. And just because this doesn't look like a traditional cubic, so many x cubes plus so many x squares, it doesn't matter. I still just set x to 0. So I'll get y equals, well, I've got 0 plus 2, which is 2. I've got 5 minus 0, which is 5. And I've got 2 lots of 0 plus 1, which is 1. So my y is just 2 times 5 times 1, which is just 10. Let's think about the x-axis. So I set y to be 0. I've got 0 equals x plus 2, 5 minus x, and 2x plus 1. And this is where it's really nice of them, because they've done the factorisation for you. So x is either minus 2 to set that first bracket to 0. Now, how do I set that second bracket to 0? Well, again, it's fairly obvious, because 5 take away what makes 0? Well, it's just got to be 5. But if it wasn't so obvious, you'd just say, well, I want my bracket to equal 0. And then I'd just solve it. So I'd go add x to both sides, so 5 equals x. Okay, don't need that, but that's what you would do. And for the second one, 2x plus 1 has to equal 0 for that third bracket to be 0. So that means 2x must equal minus 1. So x must equal minus a half. Okay, and now I've got my axes. It's going to cross at 5, minus a half, and minus 2. It's going to cross the y-axis at 10. I know that the shape has to be this one over here. So I know it's going to start in the bottom left. It's going to come up, down. Oh, I've made a mistake somewhere. So let's have a look. Oh no, sorry. My mistake was it's a negative cubic, because I've just totally taught myself out of the wrong thing. I just said the wrong thing. It's a negative cubic, which is why it looks like this. I do apologise. So it starts in the top left. Okay, but could you see how I couldn't make that work then? Because I couldn't get it to go through the y-axis at 10. So it's going to come down, up and down like that. Okay, so sometimes if you put all your points on your axes, if you're making a mistake, it can alert you to it. Okay, now then, so let's think about our type. What type is this? I've got an x multiplied by a 2x multiplied by a minus x and multiplied by a minus x again. So this is going to tell us what that highest power is. And obviously that's going to make 2. Now I've got a positive times a negative times a negative. Well, these two combine, negative times a negative make a positive. So all of this is going to be positive. And so it's going to be 2x to the power of 4. So my type is a quartic, and it's a positive quartic. So what does that look like? It looks like that. Okay, so it starts in the top left, wibbly wibbly wobbly, finishes in the top right. Then I've just got to do my axes. Where do they cross the axes? So again, on y-axis, x equals 0. So my y is going to be 3, because the x 0 plus 3 is 3, times minus 1, times 1, times 4. Because if I set x equals 0 in each of those brackets, that's what's left. So I've got 3 times minus 1 times 4, which gives me minus 12. And then again on the x-axis, I set y to be 0. So 0 equals those brackets, each of them individually, all multiplied by together. So the only way that can be 0 is if one of the brackets is 0. So either x equals -3 for the first one, x equals a half for the second one, x equals 1 for the third bracket, and x equals 4 for the final bracket. And then draw my axes. So I've got -3, a half, 1 and 4, and it crosses the y-axis at -12. And I go back, what type of shape was it? It was this one because it was a positive quartic. So it's going to start, it's going to come up, down and up. And honestly, they can be drawn pretty terribly. I mean, really, it'd been better if I'd have drawn that a bit more like that. But it doesn't matter. They're not too fussy about how bad your drawing is, as long as you put all the information on the graph. And by that, I mean put these points on there, and you actually make your line go through the points. Sometimes I'll see pupils draw their points on, and then it'll go like this, and it'll go, and like the examiner's not going to mark that right, because you've got to make your line go through your points. Okay, so let's have a look at another example, because this is introducing, if I go back, this thing here, touches, and I'm going to explain that with this example next. So this example is a bit of a funny one, because I've got to decide what type it is. And if we think about this, I've got an x in this bracket, and I've got an x squared in that bracket. So it actually becomes an x cubed. So it's a cubic and it's positive. Okay, so if I just remind myself, that looks like that. I can do the axes again, just the same, because the first two things that we do are the same. So on the x-axis, y equals 0. So I'll go 0 equals x plus 3, x minus 2 squared. Now, what does that x minus 2 squared mean? Well, actually, it just means x minus 2 times x minus 2. So you know what? I'm going to write it like that now. So either x is -3, x is 2, or x is 2. And this is when we call it a repeated solution, because we've got a solution, but it's there more than once. And in this case, it's there 2 times, all right? So there where it crosses the x-axis, and for the y-axis, I set x equals 0, so y equals 3 times -2 squared, because imagine we're putting 0 here. So what am I left with this bracket? I'm left with -2 squared. Okay, so -2 squared, negative times negative makes a positive, so I get y equals 12. Right, now before I do anything, I'm going to put those 3 things on the graph. So I've got my -3, and I've got my 2, and I've got y equal 12, and I know it looks like this. And what happens is, we start at the bottom left, we come up, we come down. Now, effectively, I've got to go through the point x equals 2 twice. So that means I go through the point x equals 2 going down, and then I instantly have to go through the point x equals 2 going up. So what that means is I don't actually go through the point x equals 2. And so when we have a repeated solution, what we have is what we call a touch on the axes, because it has to go through and then instantly come back again. Okay, so x equals 2 is classed as a touch. So when you have something squared, you're going to touch the axes at that point. And you can have touches coming down and up, or you can have touches going that way as well, where it just touches the axes like that. But a touch means you go in and out instantaneously. So effectively, you don't actually end up going through the x-axis. Okay. And here we've got another one. Now, the first thing I notice is I'm going to have another touch because this is going to give me a repeated solution. But before we get that far, let's think. Type. What type is it? Well, I've got an x times a 2x squared times a minus x. What's that going to give me? Well, it's going to give me an x to the power 4 because I've got an x squared, and an x. And I've got a positive squared, and a negative. So it's going to be a minus. And because it's actually going to give me a minus 4x to the power 4. So it's a quartic and it's negative. So let's do my tiny sketch. That's going to start in the bottom left and go to the bottom right. So it's going to look like that. Right, axes. Because we do the type, then we do the axes. So let's do crossing the y-axis. We set our x to be 0. So y is going to be 3 times minus 1 squared times 5. Because if I look, if x is 0, I've got 3 in that bracket. If x is 0, I've got minus 1 squared in that middle bracket. And if x is 0, I'm just going to have 5 in the final bracket. So what does that give me? I've got, now minus 1 squared is positive 1. So I've got 3 times 5 is 15. Okay. And then for the x-axis, I set y equals 0. So I've got x plus 3. Again, I'm going to write this separate, this 2x minus 1 squared, because it really emphasises the fact that I've got a solution twice. So I've got, therefore, not equal, sorry, therefore x is minus 3, x is a half, x is a half, or x is 5. So I've got my repeated solution, which means we've got a touch. Okay, so let's draw my axes. I cross at minus 3, a half, and at 5. My half is a touch, remember. And I cross the y-axis at 15. I look at my shape that I've already decided what it's going to look like. So it's going to look like this. It's going to come up. Sorry, it's not going to look like that. Oh, it was going to look like that, but I didn't explain myself. So it's going to come up, it's going to come down. Now at x equals a half, it has to be a touch. So it doesn't go through, it only touches as it turns. And then it goes up and turns, sorry, and put. If you ever do that, just move your x equals 5 over a little bit. So, and it goes through at x equals 5. And so the main thing to remember here is the touch there. Okay? Right, got 2 more examples for you to do, and then I'm going to get you to do some, and I'm going to be quiet. So again, this is, what's the type? Well, look at the highest power. It doesn't matter that it's written the other way round. You look for the highest power, and the highest power is 3. And the highest power is a minus, so it's a cubic, but it's negative. So again, do myself a little sketch. Negative cubics start high and finish low. And when I talk about that, I'm always going from left to right, because that's how we read and that's how we look at graphs. So now my axes. So let's set x equals 0 for our y-axis. So our y is going to be 0, because we've got 3 lots of 0 squared minus 0 cubed. Now set y equal to 0. I've got 0 equals 3x squared minus x cubed. Now they haven't factorised this one for us, but if I look, they've both got a factor of x squared. So I'll take x squared and 3 minus x. So I say either. Now remember, this is x times x, so I've got x equals 0, x equals 0, or x equals 3. I've got that repeated solution again because I've got x times x, because that effectively, what I could have written is x times 3 minus x. So that means I've got a touch at x equals 0. And now I've got everything I need to draw it. So again, get my lines. I need at 3 and at x equals 0, but this is a touch. I know the shape because that was the first thing I decided. So it's going to come down. It's got a touch at x equals 0, which means it has to go down and then straight back up again. And off we go. And then we've got our graph. And the final one, now this is the one where you have to put together everything that we did over the last couple of lessons, because we are going to have to factorise this. So I'd have to use my factor theorem and all the rest of it. But I'm going to go through the same way I always do. So my type, highest power is 3. So it's a cubic and it's a positive cubic. My axes, well, when x equals 0, y equals minus 9. That was the easy one. Now, unfortunately, the hard one is 2x cubed plus 5x squared minus 6x minus 9. So I've got to use my factor theorem. If I try x equals 1, I've got 2 plus 5 minus 6 minus 9. It doesn't equal 0. If I try x equals minus 1, then I get 2 lots of minus 1 cubed, which is minus 2. 5 lots of minus 1 squared, which is plus 1, so it's plus 5. Minus 6 lots of minus 1, so that becomes plus 6, and minus 9, and that does equal 0. So therefore, x plus 1 is a factor. Now I'm going to do this over on the right hand side of my page, but then I'll get rid of it in a minute. So just to do it nice and quick, x plus 1 is a factor. 2x cubed, so we need 2x squared times 2x squared. We want 5x squared altogether, so I need another 3x squared, so I need a 3x and a 3x. I want minus 6x altogether, so I need a minus 9x to give me minus 6x. So that means that's minus 9, and that's minus 9, and that's my check. So I've got x plus 1, and then I need to factorise 2x squared plus 3x minus 9. I need minus 18, and they need to add to make 3. So it's going to be 6 and 3, and it's going to be plus 6 and minus 3. So let's do my grid method again. So I've got 2x squared, 6x is minus 3x is a minus 9, 2x. So that makes that x, that minus 3, and that, not 2, 3 even, and check in the bottom corner. So my factorisation gives me x plus 1, x plus 3, and 2x minus 3. And I know I was quite quick there, but that's almost this type of speed that you need to be getting to with this. Okay, nice and quick. It becomes second nature. All right, so my solutions are x equals minus 1, x equals minus 3, or x equals, now 2x minus 1 equals 0, so 2x must be 3, so it must be 3 over 2. And now I can draw my lines, my cubic. So I need minus 3, I need minus 1, and I need 3 over 2. It crosses the y-axis at minus 9. I didn't actually do my little sketch of what a positive cubic looks like. It looks like that, starts in the bottom left and goes up. So it's a nice straightforward one. And actually, this is one of those ones where you can't draw it the one way round, because it's just impossible to go through those 4 points drawing it the wrong way round. And that's it. So, have a go at these 5. Okay, so remember with that last one, you've got to use your factor theorem like I did. So it's a bit of a longer one. But have a go, press pause, and when you want to see the answers, press play. Okay, so first one, type is a cubic and it's a positive cubic. Okay, so we do our axes. So we put when x equals 0, y equals 0. Now again, when we factorise, we can see each of the three terms has got a factor of x in, so take that factor of x out, and then you've just got a quadratic which you can factorise like I did on the left. None of those factors were repeated, so there's no touches. Positive cubic, so it's going to look like that. Right, number 2, what type? Again, cubic, and it's a positive cubic because it's got a x to the power 3, and that's a positive in front of it. Do your factorising. Now, if you look with this one, we've got our bracket repeated. So we've actually got this repeated. So we do have a touch, okay? And so we have a touch. So it starts in the bottom left because it's a positive cubic. It has to touch at x equals minus 4. So it comes up and touches and then looks like that. Right, what have we got? We've got a quartic because we've got here an x squared and here we've got an x squared. So that makes an x to the power 4 and it's positive. Okay, let's do our axes. So we know when x equals 0, our y equals 36. When our y equals 0, we've actually got two solutions, but both of these solutions are repeated. I didn't write this out like I did with the example, but both of them are repeated because I've got x equals minus 2 and x equals minus 2, x equals 3 and x equals 3. So I've actually got two touches in this one. Now, remember what a positive quartic looks like. It looks like that. So if you imagine I've got two touches, it's effectively going to look like that. And that's exactly what it looks like at minus 2 and 3. Now, what have I got? I've got a cubic because I've got a minus x and an x squared. So that's going to give me a minus x cubed. So I think I've written down there, it's a negative cubic. Okay. Let's find where it crosses the axes. Put x equals 0 in and you get y equals 4. Put y equals 0 and you get x equals 4. Oops, I've gone a bit big there. Or x equals 1. But that one is repeated. So therefore, I've got a touch at x equals minus 1. As I said, it was a negative cubic, so it's going to look that way round. So we've got a touch at minus 1. It comes up to go through the y-axis at 4 and then comes down to go through the x-axis at 4 again. And number 5. Okay, so it's a cubic, positive cubic. Find where it crosses the y-axis nice and easily. Need to use your factor theorem to find where it crosses the x-axis and do all of that. And then you get your three factors. So you should have got x plus 1, 2x minus 3 and x plus 3. You find out where it crosses the axes. There's no repeated solutions, so there's no touches. And so it should look something like that. Okay, so hopefully they were okay. If not, maybe rewind and have another look at any of the particular parts that you weren't quite understanding, and have a go at the worksheet on Edmodo.